Okay, hi everyone. Um, Thank you very much for coming back to us here at the School of Engineering. We're about to get underway with our live virtual tour of our facilities, and we have with us a great group of students and our amazing technical staff who are in their labs and various other spaces around our engineering complex that are excited to show off their spaces, talk to you about who they are, how you'll interact with them, and maybe identify a few of the courses that you may be taking that will have you go through those lab spaces. So we're going to get into it right away, and I'm going to take us, or I'm going to hand it over to Daniel Igra. And Daniel is with our Engineering Society. He is the past president, so he's on his way outgoing. He's done a wonderful job over the last year, and we thank him for that. And Daniel's going to show off our some of our common spaces, our Atrium, our Engineering Society office, and the wellness space. So over to you.
Hi, everyone. Thank you for that intro, Chris. I'm the first stop on this tour. I'm sort of doing the common areas as well as the NSOC office. So why we wanted this spot to be first is usually in an in-person virtual tour, this would be your first stop on the campus tour of the engineering building. Usually there would be booths in the atrium. And people would line up and then they would go on tours. So we sort of wanted to keep that same aspect in this year's tour. So I'm sitting in the Adams Atrium right now. As you can see, it's very spacious. The ceiling goes up 3 floors, and you can see into some of the labs around you. But this stop on the tour is basically like the common area where there's loads and loads of tables. There's usually like hundreds of students in here working in between classes. They're just relaxing, catching up with friends. This is a good area to study when you have some free time slots in between your classes, or it's a place where people can have lunch. There's some microwaves, which I'll show you later in sort of the other common area spaces. And you'll mostly find students on these tables working in groups or catching up. If you ever have like a meeting with a tutor or like a lab group, most of the time the atrium would be the area where you'll go. So yeah, other than that, for students, it's also an event area. So as you can see, it's very spacious. So every now and then, either the School of Engineering or NSOC will book out the atrium, move all the tables out of the way, and sort of have an event. So that happens a few times a year. From the NSOC perspective, which is the Engineering Society, we will have like the Professional Development Conference, which is usually maybe a panel of some profs and some industry professionals. So that's sort of the rundown. And I'm going to pick up my laptop now and sort of walk you around and to go to the next spaces. But hopefully it will go well and you'll get a good gist of the atrium and sort of what's going on in here. So right now I was just sitting at one of the high tables. So as you can see, there's many tables as it stretches back. There's some long tables. There's some plugs for everything that you'll need. So I'm just walking over here to the next stop, which is the Engineering Society office. So right attached to the atrium, there's this little office right here. You can see some of the merchandise that's in the stores. So at the panel on the previous section, some students were wearing Guelph Engineering sweaters, and sort of this is the area where you would buy them. Right now we're doing it in the bookstore, but usually you could just swing by here and pick them up. I guess I'll speak a little bit about the Engineering Society now, since I'm sort of at that part of the tour. So as Chris mentioned, I'm the current president of the Guelph Engineering Society, but I am on my way out. I think I have maybe a month left, and the incoming president is starting to pick up some of the tasks and starting to organize the next team. So Guelph Engineering Society, or we usually call it NSOC, we are structured on 3 pillars. We focus on events, services, and advocacy. So before I go into those, just to explain who we are, we're elected by the student body to represent all of the students within the School of Engineering. And then from there, we focus on our pillars, which are advocacy. So we'll speak on behalf of students if there's issues in courses. We also run events, just like the ones I talked about before, like the Professional Development Conference and some other fun events throughout the year, as well as we also have some services like a lab fund, which help provide money for student projects. So yeah, that's pretty much NSOC in a small bubble. Hopefully you'll hear from us. If you are coming to Guelph, you'll get some emails about O Week, the first event that we usually host. It's a Guelph, NSOC usually hosts a week of events, and I hope that would be something you're interested in. And then moving to the last stop of the common area, it's just in the room. This is the well sort of stuff. So it's a nice place to relax, which is a little bit more quiet than the Atrium if you just want to chill with some friends. And I have seen some people take naps on the hammocks every now and then. Okay, yeah, so that's pretty much the common areas. And then the last thing I wanted to show was the microwaves and fridge for people that people that are eating in the Atrium. So yeah, that's pretty much it for the common areas, and I'll pass it back off to Chris to continue the rest of the tour. Thank you very much.
That's awesome, Daniel. Thank you very much for that look around. The Atrium is a huge space for us. As Daniel had suggested, we have our trade shows and events, and it's just a hive of activity. And if we were lucky enough to have you on campus with us today, that's where we'd be staging out of. It's a great feature of our building, as is the NSOC office and the wellness space. Thanks very much. We're going to shoot over to Spencer Ploger in the Robotics Lab, and he's going to take you through that space, which he's very, very familiar with.
Yes, thank you. Hi, guys. Yeah, so like Chris said, my name is Spencer Ploger. I'm a fifth-year engineering systems and computing student, and I'm joining you from the Robotics Lab here in the Richards building. So this is like the coolest lab on campus. Sorry, everybody else in this tour. We have a lot of awesome robots here, so I'll just go through them really quick. Okay, there's a KUKA, a FANUC, a Baxter, a CRS, another Baxter, another CRS, another FANUC, and another KUKA. And these robots, except for the Baxter is like a specific learning robot. These are all robots you use in industry. So like these are real life, actual robots. And when you take robotic systems in fourth year, you can learn to program every one of these robots. It's super, super, super cool. I'm going to give you guys a little demonstration of something you can do. So hopefully you can see this. Here's the KUKA robot. And here's like a train track. So I'm just going to put this down here. You can see the track. So you learn all this stuff in class. Like, it's crazy that you can come here and play with this for marks. You can play with this robot. You can move it around. You know, it's a lot of fun to play with. And getting taught this by a prof is really sweet. This is also this is a program I wrote that I'm going to show you guys now that pretty much just pushes this train around the train tracks. So give me 1 sec to get it started here. Okay, so, oh, there we go. Yeah, so this is actually a task. Oh, I pushed too hard. This is actually a task you do as part of your lab when you take this course. So each robot in this class has 3 tasks that you do with it for marks. So this is the 3rd task for this robot, and as you can see, it's just smoothly pushing around the train on the tracks, which is awesome. This is a really good skill to have. It's a valuable robot to learn to use. Like I said, it's the real deal, and just having access to awesome things like these in our labs is really, really sweet. This is like one of the coolest places in our engineering building, and I highly recommend, if you come to Guelph, you take Eng 4460 robotic systems in your upper years and learn to use all of these robots in this awesome space that we have. So Chris, thanks a lot. I'm happy I got to show that off, and I really hope that the attendees to this tour get to experience this stuff from themselves. Thank you.
Excellent. Thanks, Spencer. That's great. Spencer's with the robotics team. He's very proud of his club and the lab that he spends a great deal of time in. And Spencer is an amazing ambassador for us in reaching out to potential students and promoting all things that are awesome about Guelph engineering.
I can't say enough good things, as you can tell.
Yeah, that's it. So our next stop on our tour, we're going to be going to our biological lab, and Jacqueline Fountain is hosting us there. And Jacqueline is the lab technician that lives and works and breathes in the biological lab. So over to you.
All right. Hey, everybody. So I wanted to just give you a tour of the lab briefly. I am tethered by my webcam cord, but you can see over there, we have robots in here too. Ours are two Instron machines that do tension and compression testing on materials. We also have a fatigue tester there, and all of these ones are used in biomaterials, which is a third-year course. Most of mine are third and fourth year courses, so if you continue in this, then you'll see me eventually. We've got a biosafety cabinet over there and our fume hood where we do our chemical work. Over here is where we do most of our stuff for Biosystems 2, which is another main course that I cover in this lab. We've got some other cool bioreactors back there. So the big black and silver guys. Those ones we use to make, well, ferment things. So we have fermented like beers and things like that and passed in them, or we fermented like wheat shorts and things to try and utilize food waste that comes out of different facilities. So if you like to do cool things with small organisms, then this is the place for you. Yeah, I guess back to you, Chris. It's just short and sweet.
That's just fine. Thank you very much. Thanks, Jacqueline. I just wanted to make a note here as we're moving around the building. We are taking any questions that you may have, whether it's to do with anything you've seen on the tour or just in general. If you have questions, please post them in the dialogue or the Q&A feature, and one of our team members will get to those along the way. So we have a couple of questions here, and maybe Jacqueline, before I let you go, can you comment? We have a question here. What kind of training is needed to use the various lab equipment? Are you able to answer that in general terms, or at least specifically to your lab? Are students trained as they come in the first time?
Yeah, for sure. So we do safety training on the first lab day usually, which includes kind of basic fire safety, hazards specific to whatever lab you're working in, and just like general lab safety stuff that it should become obvious the more you work in labs, like don't eat in the lab usually, or that kind of thing, like leave your coffee in the hallway. And then, yeah, what to do if the fire alarm goes off, what to do if someone gets injured, that kind of stuff. So then for the particular instruments and stuff like that, we usually do some training like day of. We have a lab manual that goes out to the students ahead of time, which they're supposed to read. And then the day of, we walk through like what buttons to press and not to press on the Instron, and like how to keep yourself safe and others safe, and then how to operate them. So yeah, so we do specific training on the day of the lab usually, and then basic safety training on the very first lab.
Excellent. And that will be similar to different labs. So there will be different procedures and things that you need to know in each of the different labs that you go, but that's a great introduction to entry into your lab for sure. And I know specifically, and can talk about the machine shop a little bit, as you move through sort of hands-on opportunities with the different tools in the machine shop. There are varying levels of training that you need to pass before you're able to work on the bandsaw, for example, and things that can be certainly do have more advanced safety issues. So thanks, Jacqueline. And really appreciate you taking part today. And so we're going to move over to Mike Spiegel now. And Mike is the lab technician in the Sustainable Energy Lab. So take it away, Mike.
Hi, everyone. So yeah, I'm in the Sustainable Energy Lab. It's actually 2 labs. It's one of the larger ones in the school. I'll take you a bit of a tour around it. You generally don't get to come up to this lab until the third and fourth years, and then you usually get sick of me because, especially if you're in mechanical, you'll see me for up to 5 courses in your third year alone. I like to say I get a good relationship with people, but it all depends on how everybody can put up with my sense of humor. I'll kind of go around and show some of the equipment. So this is a mechanical lab. So we do some of the basic, or not the basic, the group third year programs. So thermodynamics, heat and mass, applied fluids, things like that. So in the lab, we also have some research equipment up here. So we've got our fume hood here in the corner, and then a research piece of equipment that's a wind tunnel. Then over here, I have a couple of tube and shell heat exchangers. The rusted one has been used lots. The other one I'm still working on. And then we have a centrifugal pump and a hot water tank that was used for the heat exchanger. And then that blue framed piece of equipment is a heat pump. It's been exploded out so that we can see all the parts. We have another one on this side to try and double up some of the equipment. We also have a vacuum pump, which we use to boil water at various different temperatures and pressures. And here's just another tube and shell heat exchanger, that gray thing up there on the corner. Those are for some of the mechanical courses. As we go along, we also have some more pumps and a radiation sensor. So that's done in heating mass, which is one of the more common courses. And then we have a exploded or a taken apart air conditioner, and we'll go over how that works and show you on a real life one what all the different pieces are. And then as we're going through, we have this large piece of equipment, which is a HVAC or heating, ventilation, and air conditioning trainer. And that's a nice lab as well. And just some research equipment. So I believe beforehand, some of the students were saying that they really wish they would talk to some of the profs earlier to find out what they can help them with. And these are some of the examples of research equipment. Then, because I'm a sustainable energy person, I also deal with solar panels. So this solar panel here, and then we have a couple more in the lab, are used to teach you guys the basics behind them. So we have a group of lights, and then on the back, we just have a number of meters in order to tell us the voltage and current, and then also adjust the power. So this is just some of the equipment that you'll be able to use in your third and fourth years for some of your mechanical courses. So I'll just keep going through. We've got another pump. So this is what simulates a Peloton turbine. So that's something that's used in hydroelectricity generation. Then over here, this is another large pump, which is a Francis turbine, which is the same as, or the same style as Niagara Falls, but obviously much, much smaller. And then this equipment here are bomb calorimeters. Nice fancy name for being able to explode or blow up different materials. Anything from corn or wood. We could put a donut in there, or a steak, or gasoline or coal, but anything that we want to find the energy content to, we can use that equipment to do so. Then on this side is kind of the classroom area. Once again, in the third year, we'll have a couple of classrooms. It's a nice wide open spot. Also for a number of your design courses. This is one of the labs that I'll generally be able to give 3 or 5 or 6 groups the ability to come non-COVID times and work on their design projects. Actually, here in the corner is a domestic hot air heater that we were trying to build, that the parts are right here that got held up from last COVID, but I'm pretty sure it might get started again at another date. So that's one of the other things in the lab that we're able to do. And then you've probably seen in some pictures that there are solar panels and a wind turbine on the roof of Thornborough. All that comes down over here. We have some inverters for the solar panels and the wind turbine, and they just come into a battery bank. And then we use that to charge a couple of the electrical receptacles on various floors, so that if people are studying, then you can, if you see a green receptacle, you can know it's being charged just by our solar panels and wind turbine up on the roof. That's most of my lab, I believe. yeah, I primarily do third year and fourth year mechanical, sustainable energy classes, and I'm always happy to help out. And I also like, as all of us techs do, helping with the 41X and other design projects. So I'm happy to answer questions later.
That's great. Thanks, Mike. Yeah, if there are questions for Mike in regards to his lab or any aspect of the things that go on in there, please take a minute, post one in the Q&A, and we'll ask Mike just to keep an eye on that Q&A board for the next few minutes. And I'll just make an announcement to anybody on our panel that has either presented or is waiting to present. We have quite a few questions coming in. Anybody that wants to hop on there and try their hand at answering a question, we'd really appreciate that. So we're going to keep our tour rolling. Again, thanks, Mike. That was great. We're going to keep our tour rolling and head over to the environmental lab, where we have Joanne waiting for us. Joanne is the technician that, again, like Jacqueline, lives and works and breathes in the environmental lab. So over to you.
Hi, welcome everybody. Welcome to the lab. The lab I'm going to show you is mostly water resources engineering and environmental engineering students do courses in here. So what I'm going to try to do is swing my camera around and let's see, got a few setups. So the first course that you'll come into the lab for is in the winter semester of your second year. It's called Environmental Engineering Systems. So you're looking at how to model and quantify different types of systems. So the little example I have here is we're looking if we add a contaminant into our one system, and then we can model how it moves through our other system. So we eventually start to see it move into the other tank. In this case, we could be looking at it, maybe we're thinking these are two lakes joined by a river. If there was a spill in the one lake, how long will it take before the contaminant reaches the other lake? So with this course, you're going to learn how to do the modeling with computer programming. And with this lab specifically, you compare your computer program model data with your experimental data and kind of see how closely they match up. I'm just going to slide down. The next course you'll be in here for would be the fall of third year. It's a water quality course. So we look at how to measure different water quality parameters. As well, we look at how if we change treatment, water treatment or a wastewater treatment, how does it change those water quality parameters? And this is kind of cool. So we buy, it's a prepared test kit from a company along with the instrument. So it has a little barcode reader. It kind of spins the test tube around and then it just spits out your result. So you don't have to do as much of the calibrations already done for you. I just like how it spins around. I know, easily amused. The next one, little demo I have here, this is for a third year course, mass transfer operations. And what we're kind of looking at is we have, in this case, a resin, and we're just looking at the capacity of the resin to remove contaminants from water. So we see how much of the water can we put through, when does it become saturated, and then how would you use that information when you're designing that kind of treatment system. And then just moving down here. So environmental engineering, it's not all about water. We also do air. That's also one of the areas that we run labs in. So in third year, there's a air quality course. And then in fourth year, there's a control of atmospheric particulates course. So we have this instrument. It measures particles in the air, and it puts them in different bins based on the size. So it totals up how many of those particles. And then we look at different filters and how efficient they are at removing particles from the air. So that's about it for me in the environmental engineering and water resources lab as well. So yeah, thanks for visiting. It was nice to meet everybody, and I hope to see you here at Guelph in the fall.
That's fantastic. Thanks, Joanne. Really appreciate you being in the building today and showing off your lab. That's great.
Oh, and I mentioned fourth year design. You also might, depending on the project you pick, you might be working in this lab too.
Awesome. Thank you. So we're going to keep rolling here. And Stephanie Kodiitis is in the materials testing lab waiting for you. And Stephanie's a grad student and a mechanical engineering undergraduate grad as well. So she's going to talk to you and show you around our materials testing lab. Are you there, Stephanie?
Can you hear me?
Yes, we can.
Cool. So my headphones are muted. Hi, I'm doing my PhD. I came here in 2014 for mechanical engineering. It's been way too many years. So I'm currently the material science TA. So we've just been filming the labs instead of actually performing them. This here is an impact tester. So basically you'd put a sample in and this big hammer would come down and indicate the force it took to break the sample. So that's your third lab. Here we have a compression tester, much like the one you've seen before, except this one is a lot larger. Here we have another grad student just working on the tensile tester. This is the same thing, except it pulls things instead of compressing them. The third lab that we do involves heat treatment, or the last lab we do involves heat treatment. So this is our prep room, and I'm currently doing an experiment. We have a hardness tester, got two little furnaces over here, and we have microscope and a micro indenter as well. These are usually used by your TAs. However, you will be in the room when they're being performed, and you get to watch a lot of stuff break. If you're doing research or your capstone project, this is also where you may end up spending a lot of your time, but it's predominantly used for second year material science. So that's really short and sweet, but you'll obviously see it when you take this course. It's a fun lab. You get to break stuff. And, you know, it's a good time and very fundamental for all the disciplines.
That's awesome.
Cool.
Thanks,
You,
Stephanie. Yeah, so if you're a student that likes to bend things, break things, stretch them, smash them, this is your lab. Great. Thanks for spending some time with us today, Stephanie. I like the ears. So we're going to move on to Ryan Smith. Ryan is our technician in the fluids lab, and he's waiting for us there, I believe.
Yes, thanks, Chris.
Thanks, Ryan.
Everybody, my name's Ryan Smith, as Chris mentioned. I'm an environmental and water resources lab technician. So if you're in those two disciplines, I'll probably see you every semester from your second year on. If you're not in enviro or water, the nice thing with one of my labs is I do the fluid mechanics course, which is right here. So here's the lab, and everybody in engineering will have to take fluid mechanics during their second year. So I do get to see pretty much everyone at some point or another, whether you're winter semester or fall semester. We run both semesters. So I just have a few things set up here. So when you come to the fluids lab, there's a few things we do. One, we have a minor losses experiment here where we measure the energy losses as we go run our fluid through a pipe. So we've got a pipe contraction, a wide angle diffuser here, a right angle bend, and then we can monitor the pressure and calculate the energy loss for each thing. On this side, we have a jet impact tester. So we've got different vanes we can test out, and these are vanes of a turbine wheel. So we can test out different shaped vanes to figure out what design for a turbine would create the most energy output. Okay, turn it on for you. So that's one of our vanes running right now. I don't know, hopefully it's not too loud for you guys. That's basically it for the fluids. One other nice thing I get to do with the Enviro Water guys is I get to take them out to a couple field labs. So I've brought some field equipment to show you guys that we do. So one of the labs we do is a noise lab where we actually have to map the campus with a noise map. So students will typically go out in groups of 3. They get a small section of the campus, and then the whole class will eventually do the entire campus map and pool their data together and create a large campus map. Another thing I get to do is stream gauging, where we get to actually go out into Speed River in Guelph, down on Gordon and Edinburgh. And we get to wade across through the river, put our hip waders on, and get some current velocity measurements and get a current profile of the stream. Finally, I'm in the middle of running 2 weeks of groundwater lab. So I've got some water level tapes that we go out and monitor the wells. Basically, we'll pump out water from a well to get the water level down, turn our pump off, and then we'll monitor to see how long it takes to get back to our original level. And that gives us an idea of the hydraulic conductivity of our area. I think that's about it I have for you guys. Hopefully you guys choose Guelph, and we'll see you in your second year in fluid mechanics.
Thanks, Ryan. Really appreciate your time there and showing off some of the equipment in the fluids lab. That's excellent. So we're going to keep on rolling here. We're off to one of our many open access computer labs. Abhinav Chatterjee is waiting for us there, and he's going to give you an idea of what these, what our variety of computer labs look like, and how you can use them, and the benefits of having these labs available to you.
Thank you so much, Chris, for the introduction. So yeah, my name is Nav, and I'm a 5th-year water resources engineering student. And right now, I'm in one of our 6 computer labs. This computer lab sits about 30 people, and this is one of our, I would say, smaller sized labs. And we have about 4 really large labs on the other end of Thornborough. To my right is a mountain cafe where you can get your food, and there's a residence right there. So anybody who lives in South in the future will have really like small amount of time between your classes here and your labs here. So in your computer labs is where you spend most of your time doing report writing, doing all your engineering analysis. So in your first year, some of the softwares you'll be using is SolidWorks. And you'll be doing 3D modeling and doing a lot of stuff with AutoCAD and AutoCAD mechanical and electrical. So these are some things that you'll focus on in your foundational years. And depending on what stream you're in of engineering and where you go towards, you'll be using more complex engineering tools to use in your projects. And you can also use them on your resume. And while you go on your co-ops and your work terms, you'll be able to cite those sources and cite your projects while you work on. So I wanted to show you, so this is my project from second year. So in your second year design course, I hope you can somewhat see it. It's a really huge computer. You get to take apart an engine or a lawnmower or a big machine and take apart all the components and model them in SolidWorks. So I modeled a piston. I don't know if you can see it too well, but this is just one component, and then you kind of put it together in SolidWorks using some sort of animation. So we made an animation that kind of looks like that, and essentially you and it really teaches you how to be able to work in a team and use components from your peers and then put them together. So there's a collaborative nature towards any of our engineering majors where we do projects with other majors across the entire engineering degree. So yeah, this is in a nutshell what you'll do with SolidWorks in your first 2 years. And I'm in water resources engineering, so we do a lot to do with watershed design and flow analysis. So I'll show you one of my projects that I'm working on, which is extremely cool. I'm doing a hydropower dam design in one of the biggest dams in the Grand River watershed. So this is part of what it looks like. It's a stream. You can animate this stream and look at the flow, have your culvert design as well. And you know, you can do a bunch of things with these computers. They're really highly powered and remotely accessible from the computers you have at home. So while a lot of people are working virtually in their houses, they can get access to these computers and use all the softwares in them. So that is a really cool feature that being a Griffin in engineering offers you. So I really hope that this helps you gain a little bit of insight on what your engineering days may look like. We spend about 10 hours of our days here sometimes doing report writing and also getting help from our peers while we're here. I've made a lot of friends in these labs and we've all helped each other throughout the year. So I hope you all have the same experience in a very short amount of time. Thank you, and let me know if I can answer any more questions.
Thanks, Nav. Really appreciate it. I know having these computer spaces around the building is a huge advantage for a lot of our students, and the fact that the software is loaded and it's ready and it's up to date makes a lot of the classwork a lot easier. So awesome, really appreciate it. Looks like you chose a nice sunny lab to be in there too. So we're going to call on Spencer again. Spencer has run across the building, and he is now going to just give you a little snapshot from the second, I guess it would be the second major sort of social space, collaborative space in our building, and we call it the think tank.
Yeah, hi guys. You can't get rid of me yet. I'm in the think tank. The think tank is part of the Thornborough Engineering Building. It is a really awesome common space for engineers to just sit down, study, hang out. There's a Tim Hortons that's open normally behind me. We're central to campus, so that's the university center right there. This is the bus loop. This is where you would catch your bus to go home. And if I take you through the think tank, you can just see there's just like couches. There's, you know, if it wasn't COVID right now, there'd be way more couches here. You can just hang out with your buddies, sit down. There's some tables there, and there's even more tables and just tons of study space here. Beautiful, open, bright. It's an awesome space to just hang out, sit down, study, and just work on stuff with your friends. So this is a really awesome space. You have access to it 24/7. You can get in here in the middle of the night if you wanted to, and it's normally bustling with people. So it's a great place to just meet your friends and get some help with your class stuff or just hang out. Yeah, just one more view. So that's it. It's just a huge open room in our engineering building here. So yeah, thanks. Chris,
that's great. That's it. Yeah, that's great, Spencer. Thanks. And you know what? You can actually go home now. We really appreciate you've been here for a few hours, and that's been awesome support. So
thanks,
that's
Chris,
yeah, no problem. See you, buddy. We are at the end of the live look around of the building. Now we should note that there are, countless number of other labs that service the teaching and research needs of the school. You'll see here that there is a first floor map of Richards and Thornborough as they interact. So I'll use the compass to orientation to let you know where we are. So the north-south facing building on the left side of this diagram is our Richards building. The east-west intersected by that long hallway. The engineering hallway is the Thornborough building. And in very, very general terms, you'll see on the very east side or the right-hand side of this, I shouldn't use the compass, but the right-hand side of this diagram, generally speaking, is where a lot of our wet labs are. So the enviro, the biological, the water labs, the exception being the machine shop and the materials lab in the corner. And as you move to the left of this diagram is where you'll find a few more of the dry program, or the computer labs and the robotics lab and things like that. So that's a bit of that's an overview of our first floor. Like we've said all along, our preference would be able to have you here in the building and show you around, but we're hoping that this little run through our building and getting to meet some of the faces and spaces around our school will help you think positively as Guelph about Guelph as your option for engineering in September. We're really excited to have you here with us. We did go over it in the information session, but I can tell you that the university and the school very specifically are working very, very hard to create the environment that we can welcome our students back in September. Pending any developments with the COVID-19 situation and public health restrictions, our intention is to do as much face-to-face teaching and educating as we can possibly do in September. Engineering is a hands-on science, and it's important to us that you have that experience. There may be some of our larger first-year classes that you see some lectures being done online, but your lab components and your seminar components being done face-to-face. I think our last year of educating students has proved that we can do a very good job of delivering content online, but we do in engineering believe very, very strongly that it's a hands-on science, it's a hands-on experience, and we want you in the school. So that's what we're working towards. So our tour is over. I'm going to ask, and I'm going to let all of our tour guides go and say thank you very, very much for spending some of your Saturday afternoon with us, and let you know that the Q&A board will be active until 3 o'clock. So there will be a few of us that stay online and try our best to answer your questions. So once again, I'll wave and I'm not even on video, but I'll say thank you very much to my colleagues and to the students that helped us out today. We really appreciate your support. It was a big favor. So to the people still in attendance, if you do have questions, just let us know via the Q&A board. I'm going to mute my mic. It's going to be a little quiet for a while, but we will address your questions as they come in. So thanks very much.